So then we are starting. So welcome to the webinar regarding arrays. There will be some overlap in this webinar with the syntax control webinar we had before the summer. First of all, it's nice anyway to repeat some of the array functionalities because they are very important. Also, in this webinar, we will go in details all regarding arrays in Powersim Studio. So I will quickly go through this agenda before we start. The introduction, I will show a small depth model or bank model just to show actually what arrays are and the main purposes of the arrays in Powersim. Then I will show the most normally used kind of array and the one also with most functions. Many functions taking an array, they need vectors into the functions, and that's the so-called one-dimensional array. Then to show a vector in Powersim Studio, you use the chart control. You also use the chart control to give input to a vector or one-dimensional array. If you have several dimensions, you can also use the chart control, but then you will need it for each element of the second dimension. I will come back to that. Then a very important point is the choice between explicit dimension or automatic dimension. The rule of thumb is to use the automatic dimension. Then I will show the index function. It's a bit hassling function, many people would say, because sometimes they need it, and in the cases they need it, the error messages are not really clear about how to use it. Then, to avoid using the index function, you can use a for function. Inside the for function, you're making some index variables, and they can be used in places where you, in other cases, need the index function. So the for function makes handling arrays easier to some extent. Then we will cover the global ranges, a way to kind of define one dimension in your variable and use that commonly in your model. Typically, if you have a set of 5 cities and you want to add a 5th or 6th city, then you add it in your global range and it will have influence on all your variables using that range. The numerical function will take, for instance, city number 3, which is London, for instance. If London is a 3rd city, this numerical function will return the value 3. And that can be used, for instance, to check conditions like this. Then, after this, if we have time, we will go into multidimensional arrays. They are powerful. It always gets a bit more complex than going to multi-dimensions, but that is actually what you often do. Even when running a model without any arrays at all, you already have an array in your time horizon. When running, for instance, over 5 years with 1-year time steps, you do have an array there of 5 values, 1 for each year. They are stored, for instance, to show a graph, a time graph in Powersim. So the time is already 1 dimension. Then you may add 2 more dimensions, for instance, and then you actually have 3 dimensions in your model. There are lots of confusions about what's rows and columns, so I will say a little bit about that. Then at last, I will show you very briefly what dynamic ranges are about. That is very useful, and there are many ways of handling it. First then, to this introduction. I will make a small model here now. If this is a bank account, then I say this is, for instance, $5. I make US dollars. I use a built-in one, press finish. So this one is now $5 because I'm at the start of the simulation. So I can show an auto report here showing this. It's one single value, $5. Then we make an inflow going into this bank account. And we make a constant saying something about the interest rate we are talking about. So interest rate equals, for instance, 5% per year. It's important to keep this yearly interest. It's a big difference between 5% per month and 5% per year. So I define that. So now I show this one, 5% per year. And this is the interest added. Let me abbreviate this once now. Then I double click this one because now I want two links here from the bank account and from the interest rate. Then they are not used yet. That's why they're yellow. So I double click this one, not finished yet. And I say I want to multiply the bank account by the interest rate. So then the interest added to the bank account is now a yearly rate of $0.25 because it's 5% of $5. That's a yearly value to add. So far we don't have arrays at all, but if we look at the graph here and drag this one into a graph, we see that we do actually have a small array here since we have many values, one for each day during a year. We got a bit more than 25 cents here because we have interest of the interest. So that's why we got that one. You see, when simulating only 1 year, we don't see the exponentiality of this graph. So I want to add a little bit to my simulation setting. So in place of running 1 year, I say, for instance, I want to run it until 2030. Let's try it with 1 day time step. And you see it takes a bit time to run it, but we see now it's exponential graph. Normally, I would choose a longer time step when running that many years. But for now, I do it like that. And the point is now I want several bank accounts. If I do that, then I could copy this structure like this, make a copy here, for instance, and run this one in parallel with this one. That's not the way to do it. The way to do it when you want duplicates like this, that is, delete that one, that is to create arrays of your account. So the easiest thing now would be to go into the bank account and say that I want some dimension on this one. I have two ways of doing that. I could define it here to create an array, or if I want the same value for all elements, then I could create the array by defining the dimension. 1 to 3, for instance. Then I have 3 times 5. Why do I get question marks here? That's because now actually I created new variables. You see the same happens if I make a new constant. I double click it and say this one is 7, for instance. If looking at the auto report, I get a question mark. Why do I get question marks here? That is because I am at the end of the time horizon. Or actually, it's because I'm not at the start. A constant and a level, they both have the fact that they're only defined at the start of the simulation time. So if this happens for you, the solution is simply to reset the model. When resetting, going back to the beginning, then both of these would get an initial value. Of course, the bank account, these elements in the bank account, same with this constant, it never existed at the start of this simulation because I created them when I was at the end of the simulation. So that was a side step. The point is now, you see, I get 3 elements here in the bank account. I still have only 1 element for the interest rate, but this interest added has got 3 elements. And why does that happen? That is simply because the equation here says that I want to multiply the bank account, which is that variable, with 3 elements, and multiply that one by something, by a value. In this case, it's a single value. It could be in an array there as well. It can be a scalar like it is now, or it could be 3 elements. Only those 2 options. If I had 2 elements here, it wouldn't work. I would get an error message. But multiplying by 1 element is fine. So the result of this would give me 3 elements. And to look back in the agenda here, this next point, explicit dimension or automatic dimension, has a little bit to do with the result we get here. The result of this equation is an array of 3 elements, because that's the only sensible solution we have here. And that's a very nice feature, actually. Another important thing we need to do regarding arrays, that is a way to view each element and to give input to them. In this case, actually, I want an initial value to the bank account. So I would like to create a constant here saying initial value. So far, I've just used $5 inside this one. But now I want to define the initial value in this variable, because I want to be able to change the initial value by the user. So I say here, the initial value should be an array. In this case, I choose 3, 7, and 5, end of array, and unit, US dollars, like this. Then you see the same thing. This equation creates an array. So I get 1 to 3 automatically inside here. And that is useful when I want to put this into a chart control. This is a chart control. I can, let me put it here. I drag this initial value in here. By default, I get a line from element to element. And you see it is 3, 7, and something less. You see it here in the value inspector as well. Very useful, this value inspector. I can toggle it here. Then I can also see the value of the variable. Of course, I can see it on the auto report as well. Sometimes that may not be that available. So this line is not very useful in this case. So I right click it and say I want bars in place. I also like to fill the bars when they are available. So I want to use this initial value into the bank account. So these values are used in here. So in place of $5, I say I want to use the initial value. And now I am in a situation which is a bit nice to keep in mind, that in this case, this equation creates 1 to 3. But I have, in addition, I have specified that I want exactly 3 elements in here. So if I say OK to this one, everything is fine. I can use this model. I can run it. Yeah, now I want all the 3 elements to be shown in this graph. So I drag it in again. If looking here now, you see I have the red line is unknown, because that is this bank account with 1 element. Maybe I want to change it back to 1 element. Normally I would delete this one by going into properties here and parameters. I could double click here to delete it, but it doesn't matter if it's there either, except it's here in legend. So when running the model now, you see the 3 bank accounts, they start on different values, and you see the result is that they are spread more because of the interest in the bank account. And this is much more interesting than running only one element, because now we can see that only a difference in the start value on the bank account will give this result. So this is interesting. You see this graph now, it rescaled. I could double click the graph or the chart control to scale it, but I can also do that in the variable. We recommend using the variable to do the scaling. You see we have a scale tab here. Because when doing it in the variable, all controls, charts, sliders, whatever, using this one, will use this, this range. So we could start from 0 to 200, for instance, like this. And now I can set these values. Actually, I can't set them when I'm at the end of the simulation, unless this one is permanent. If looking at the cursor here, you see it becomes a small square when I point at the top of these bars. If I'm able to change it, then I will have some arrows there in addition. So now when resetting this model, like this, and pointing here, then you see I'm able to change it. So now, since I'm on the initial time step, I can change all these values. If I go one step ahead, that's meaning 1 day of these 15 years, whatever it was. Then if changing these ones, I'm still able to change them, but they don't have any influence on the bank account, because this value is only used initially. That is shown by the dotted line. It's not a fixed line like this. These lines are used on every time step, but this one is only used initially. So anyway, I can run it with these values, I can run the entire model. Now you see it's out of scale here because I have so much larger values. But when it comes to the end, it rescales automatically. And we have kind of the same behavior, but different values. So back to my point here. I have an equation here. This equation gives 3 elements. But I have also here specified 3 elements because that's my old definition. And this is a very common, it's not a mistake, but it's it could give a bad situation. Because if I want 4 elements here, I add the 4th element, then you see I get an error message here. Why do I get this error? Well, it simply says here that that the dimension of the expression, meaning this dimension, which is one dimension with 4 elements, it don't, or it could be several dimensions as well, and they don't match the explicit dimension of the variable. And in this case, I have an explicit dimension here because I have not checked this checkbox here. So normally you should try checking this box, even if it's working fine. So I don't want to continue there. I want to say I want automatic dimension. And then you see this dimension follows the dimension of this expression we have here. Then everything works fine again with the values. I don't see the 4th one because I haven't dragged it in here, but the model is fine. If I want the 4th one in, I can drag it again, then I get the 4th element in here, and I can run with all elements. So Oh yeah, it's so small, so we can hardly see it. So to continue this one, in this regarding explicit dimension, you should use that as a rule of thumb. And it is this small checkbox. So always try to keep that one on. Then the next point, the index function. If I want to pick one of these values to see that value, then I can use a so-called square bracket. I will show that. And let me move this one a little bit away. In here, I say, for instance, if I double-click bank here, then I get an array equal to the bank. You see these are similar, that they have the same value. So, but if I want to pick out only one of these elements, then I can say I want to use this square bracket and say the third element, for instance, like this. Then I get one element, that's element number 3, because I picked that element. Very simple and easy. Then you could ask, what if you want another variable to pick this element? I don't want to use the value 3 here, but I want to use this. My index should point somewhere. I want this to be the value 3. If I try doing this, then I will get an error message. And this error message is a bit strange because it says my index is unknown. That's a bit confusing, but the reason for getting that kind of error message is that inside these brackets, it's kind of another world. You could have some index variables with the same name as variables, and they're still working in parallel. So it's a bit tricky getting this message, but you should know that when getting such bit strange messages, then you should use the index function. So if I add the index function, then I'm kind of converting from the variable world to the index world. And then it should have worked, but still it says something is wrong. But now it's much more sensible what it says here. It says that this, to be able to select one of these elements, I can't select element number 1.3, for instance. And this is a real value. So now I have 2 options. Let me show the non-recommended option first. That is to use the integer function. I could do that. I could say here that I want to convert this one to an integer. But that is actually, it is working. As you see here, if you make a slider on this index, and you see if I drag, I need to reset. If I drag this one up to 1 here, then I get the value 3, because the first element is 3 in this array. I'm picking out the bank variable and the index of the integer value of this one. So this works, but a much better way of doing this is removing this integer function like this, and I get the error message. But in place, I go into this index, because this one should be an integer value. So I say here on the type that this should not be a real, but an integer. And doing that, it all works fine. Now I can set it. And now you see this one will never be 1.7. It will be 2 or 1. If I say 0, there is no element 0. So then I get a question mark. Same if I go to 5, then I also get a question mark. This is useful in many cases. I will show another example. In some cases, you want maybe this index to be treated separately. You want something special to happen for this index, but not for others. I will forget this my index. It gets a bit too complex, but I will make an array here where I want to replace the third value by $1,000, for instance. No matter what's inside the bank account, I want $1,000 to be here. So in here, I will first show how you should not do it. It could be tempting saying that inside this one, you would use the first value of the bank account like this. Then repeat this sometimes. Let me get some more space here. Yeah, I should. So I picked the first, the second, and the fourth, but this third one, I put $1,000 like this. I show the auto report. Let me show both of these simultaneously. Here is the definition, and don't do this. This is not the way to do it, but we have accomplished to use these values except for the third element. That is something you often need to do. You need to handle one element especially, or you need maybe some other conditions than the third one. For instance, this index could have been a condition, and that would be very inconvenient doing it this way. So that's why we have the for function. That's the next point on this agenda. With the for function, routines like this gets much easier. It may look simple, but if you had, for instance, 200 elements, this would be terrible to handle it like this. So I'll show the for function way of doing this, which is much better. Make an auxiliary, put the link from a bank account, and the for function, it works the way that it goes through each element you specify in a header. I will show some more simple examples first, after this one, I mean. So I say here, I make an index variable, which should be equal to 1 to 4. This is kind of the dimension I'm using now inside here. I say that should be my result. If I put, for instance, 9 here, and that's it, then I get 4 9s, as you see. Because this function now counts from 1 to 4. When I is 1, it gives a value 9. Then it repeats this part all 4 times, and it gives 9 on all of them. In this case now, I first want to, I put it on a separate line, and I think it's easier to follow it. Now, this is what's happening inside this for function. But I don't want 9, I want a bank account. So I say bank account of this I, and now I do not need to use the index function. And this is much easier, you see, as long as you catch this way of using the for function. Inside the for function, you can use this so-called index variable, which in this place, or in this case, it will first be 1, then 2, then 3, then 4. So 4 times this will happen. So I say I pick out bank of I, and what I've done so far is to get a variable with no change at all. For the first element, I pick the first element here. The second one, I pick the second one here, and so on. Continue like that all the way through the variable. I want to get this 1000 on the third element. like we did in this variable. To do that with the for function, then we can simply use the if function. So I say if something, and that something should be if this I equals 3. I want to do it on the third time I go through these four elements. So simply if I equals 3, then I want $1,000. Otherwise, I use a bank. There it is. And this one is much, much simpler if you have large arrays. With this small one, maybe you could say it's this one is better. It's easier to understand. Maybe it could be tempting. It works. Sometimes, if you have a very complex or strange behavior, maybe this is better. But this is the recommended way. So I recommend that one. Okay. That was the index function and the for function. Let me explain again this first point. The for function is used to generate an array. What we did here, we generated this array going from 1 to 4. If I say here I want to go from 1 to 3, and you see I get 3 elements. It reads the 3 elements, and that's it. What happens if I go from 1 to 5 here? What happens on the 5th element? It gives me an error message. I'm very happy to get that error message. But sometimes maybe I would like to, for instance, get a question mark on the 5th element because it doesn't exist here. Okay? To do that, I can go back using the index function. Then I'm not using the index function to switch between these two worlds of variables, but I'm using the index function to explicit say that I want that index no matter what. So that index kind of, it makes Powersim ignore this range checking. That checking is very nice to have, but if I don't want it, I simply use the index function. Like that. Now you see, I get 5 elements here, and the 5th element is just a question mark because it doesn't exist. I have another function called isNone. Use that in other webinars where you can check for the value not a number in case you want to do that. But this could be useful in some cases. So then next point is global ranges. Very useful feature. If I want to be able to change the range or the range setting of many variables and many for functions in one operation, then we can go into the Project Explorer and double-click global ranges. I can also click the icon here, global ranges in the toolbar. If going in here, I have the ability to right-click and say I want to add a range. I will now make a range, which is very simple. I call it range test, for instance. This one, I want to go from 1 to 4, like this. And I go back to the shared diagrams. You see the symbol for shared diagrams. I have the same symbol up here. I can click here to go back to the diagram, or double click here. The bold one is the currently selected one. You also see it here left of the file menu. You see what you have selected at the moment. sometimes maybe just blank, then it's useful to see that here. Okay, so now I want to make a variable using this test range. So I make an auxiliary. Let's say I put the value 5, no unit at all. When clicking this dimensions field, then it automatically selects my ranges in what to show in this list. So here you see I have the range test as one of the elements. I can double click that one. Then it happens the same as we had in the other variables here, in this one, that I get 4 elements. They all have the value 5. Let me make a copy of this one, where the value is 7. Make an auto report of that one as well. These two variables are completely independent. But if I now go here and change the range test, go from 1 to 3, then back to my diagrams, and you see I have 3 elements in these ones. I could also say I want to use the range test in here, for instance. Now I'm on linked variables, so now I can select ranges manually and double click range test. I could of course also type it manually here. Now you see this one got 3 elements. If going to my range test, saying I want many elements, 8 elements, then I get 8 elements on all these variables using this one, including this for function. So the for function returns 8 elements. It only has 4 values, but number of elements is 8. Very nice feature used to make common changes like this. But there's more about the global ranges. You can use them for several other purposes. One of them is to give enumerations. For instance, these bank accounts, they belong to 1 city each, or whatever. So we could make some bank areas. I add the range again, so right clicking, say bank or bank cities, I could call it. This should not be a numerical sub-range. It should be an enumeration range. And you see we have lots of others as well. But this enumeration and numerical, those two are the most common kind of ranges we have. So if going in here, then we can add elements. London, Paris, Oslo. Like this. Finish. Then you see the bank cities are now these elements. So if we go in here and say that, this one should be bank cities. I would have expected an error message now, but oh yeah, here I got it. I have 4 elements here now. Bank cities only has 3. So I delete one of these values. Now you see these bank cities we have here are also becoming the range of bank, because bank has automatic dimension. So it gets bank cities there as well. Same with this one. It takes a bit more space, so I need to widen it a little bit. Like this. And now the model works. It works fine. You can run it. Yeah, we have some undefined. I can still run it if pressing the play button while having undefined variables. I can still say I want to simulate, but I get that warning to make sure we are not missing something. But in this case, the reason for this error is that I'm picking numerical elements here, while I actually have cities inside it. So in this case, I would like to replace these ones by some of the cities. Of course, I should put London first, but I could also try doing it differently. I could put Oslo as the first city, then Paris, and London, just to do something different. So now these two are more and more different, but you see we can pick the numbers into any range like this if we want to. But normally we would do it this way, and I would of course want to use my city, my bank cities inside here as well. And if doing that, then this test will not work anymore. You can see here, if using the bank, no, sorry, not bank, it should be bank cities, this one. Then it tells me that I can't do a check on the I when the I is an enumeration. That was okay when I was 1 to 3 and so on. But when using enumerations, then I need to use another function. It even says in the error message here that we should use numerical to convert to an integer. And the numerical function is the next point here on the agenda. It's a function converting the I or anything to a value. So if I say numerical of I, if numerical of I equals 3, let's see, this one is also, I remove this index. I could have used numerical here as well, but I don't want to do that now. I only want to pick the I directly. We could use index of numerical. They're kind of opposite functions. But in this case now, I don't need to go further. This bank cities will always have the same number of elements as my bank variable. So that's why I don't need the index there anymore. So this equation now gives a result where the third element is a special one with $1,000, which is in this case is Oslo. But of course, it would be much easier and much more readable if I could specify Oslo here in place of 3. If I just type Oslo, then I get Oslo is unknown because here it's looking in the variable world, the Powersim variable world. So here I also need to use a numerical function to convert Oslo to a certain number, which in this case is 3, and we will get the same result as you see here. Now Oslo is a special one. If I say I want to do this for Paris, then Paris is a special one. So now this equation is more readable than it was using only numbers. To make it even more readable, I always recommend using some indents. For the if function, I prefer this one. Not everyone agree with me there, but this is then it gets easier to read it, is my opinion. If this condition, then use that value, otherwise that value. And the comma and the end bracket shows that this has to do with the if function. Some people, they prefer putting the comma and ending bracket under the bracket for the if function. Maybe that's better. But using the indent is very useful. When you maybe have other if functions in here, you can even have other for functions. I will come to that with the multidimensional force. Okay. So to rephrase now, we have used the index function and the numerical function. The index function was used to convert a variable to an index, and the numerical function was used to convert an index, could even convert a numerical index, but we used it on an enumerated index, meaning Oslo, for instance. We converted Oslo to the value 3 to be able to do a conditional test on it. So these two functions, they are kind of opposite. So in many cases, you remember I removed this index in this rank lookup. I'm not allowed to do this index of I, but I am allowed to do index of numerical of I. If I do that, then it will not make any range tests or similar. So often I use this one if I use another range here than the one I'm having inside the bank variable. For instance, you could make sub-ranges. Let me show you a sub-range very quickly. If going in here, I could make another range saying best cities, for instance, and say this is a enumeration sub-range. Then I say I want to use banks, and I say from London to Paris, because the weather is bad in Oslo, for instance. Then this best cities, if I make a variable using that one, for instance this one here, then it picks only the two first elements inside here. And if I went the other way, then I would have got a question mark because of this index of numerical. So I won't go further on that one. I would like also to show a very, very simple example of the for function, just to make sure that that you all understand it in a good way, because it's an important function, and you should not be afraid of using it. So let's make the simplest for function there is. We say for 1 to 2 and 1, for instance. It's a bit similar to the one I used earlier, but now I've created two elements and they both have the value 1. So this value is the one being used here. So I put 13, lucky number, then I get 13 in both of those. Inside this for function, I am able to put an index variable. If I do that here, int, I could call it. I used I in the other case. I could call it anything. If my int equals 1 to 2, then we see no difference here because I'm now not using the index variable here. So the index variable doesn't have any direct influence on the result of the function, but we have the ability to use it. So if I, for instance, multiply by my index function, index variable, sorry, local index variable, then you see I get 13 and 26. Because the second time it goes through here, this int equals 2. So I take first 13 times 1, then 13 times 2. That's how simple it is. So inside this equation, now I want to put it on a separate line again, because it will get a bit more complex. In place of taking 13 times index, I would like to put another for function here. So I say for I, that's another index, equals, for instance, 2015 to 2020. Oops, 2020, like that. And for each of those years, I want just a value 4 for some reason. And I multiply it by int. What happens now? Now I got a two-dimensional array. In place of just putting 13 and 26, I put these 4 or 5 values with the value 4 into this. Let me enlarge this one to show what we've got. See, for the first element of these two, the first of these ones, that is this row now. For that one, I go through all the years 2015 to 2020, and I put the value 4 times int, which is 1. So I get 4, 4, 4, 4. And even a fifth 4. Oh, yeah, it's actually 6 ones. Yeah. My math must seem very bad here. I have 6 values, of course. Sorry for that. From 2015 to 2020. Those 6 values, I put 4 into all of them, multiplied by the index being 1 or 2. So this is a two-dimensional array. If I want to make it a bit more complex, of course, it doesn't matter if I move this multiplication by int into this inner 4, like this. I still get the same value out. And of course, I could use these numbers in place of just 4. If I put I here, then you see when multiplying by 1, I get 2015 up to 2020. When multiplying by 2, I get twice that value. So now I've created an array based on these 2 index variables. Normally we won't do that. We won't use the value of the index variable like this. We would use the value of other variables, like we did not there, but here. Here, this is a way of using an index variable or 2 index variables. But this is just an example of a simple for function where we go into 2 dimensions, 1 to 2. For each of those 2 elements we create here, we create 6 other elements. So the first row here is the value of the first element. Second row is the value of the second element. You see there is a tile here in the for function. Or let's look at this inner one. There's a tile. It's not a comma. Why do we have a tile there? That is simply because you should be able to define more than 1 dimension before you come to the value. So this is a bit, it's actually not necessary. I will make a copy of this variable here. Let's make an auto report, trying to cover all of these ones. And in this one, I will combine these 2 for functions. So you see here, I can simply put a comma between the 2 dimensions, and I get the exact same result. First dimension is the index going from 1 to 2, I int. The second one is I going through the years. And we get the same result. So doing it this way or this way gives the same result. Sometimes you may need to do it this way because you have other things you want to multiply before or after, or you have an if function around this one, for instance. But normally you could put all the dimensions into the for function. In both these cases, you see we get the result of dimensions from 1 or 2 for functions is 1 to 2 and 2015 to 2020. That's the same there and in this variable. Same resulting dimension. That's pretty simple. Okay. Then, when having this kind of matrices, we may wonder, why did this first dimension, why did that one come in the rows here? And the second one came in the columns. Actually, that's just a choice, that the first dimension comes down in the auto report. But there's nothing in the variable saying that you should have that this dimension comes in the rows and this in the columns, because there's actually no difference. You could have 3 dimensions, then you don't have rows and columns at all. If looking in the value inspector, you see we have the same values down here in the inspector. Again, remember this one. Here, you toggle it on and off here. You need to have the advanced user interface on to view it. You can right-click and choose between those. So with advanced user interface, you have this button available. And then when selecting a variable, you will see all the values of it. Very useful. And in this one, you could, for instance, say that this 1 to 2 should be in the columns. Now both of them are in columns. Then they are listed in one long row. But I could put that dimension in rows. And now you see in the view here, I have transposed the variable. But I haven't transposed it actually. I'm just viewing it differently. So keep that in mind. In this webinar, we don't cover export to Excel and so on, but we have covered that before. And then I mentioned this flip function. You're able to flip the information when sending it. That is actually transposing it. Sometimes you may want to transpose it, and then of course you have a function to transpose the values of a matrix. When you have 2 dimensions, you could say transpose of this copy of auxiliary 3. Really stupid variable names. But now you see the values are transposed because of that function. When running workshops, we often give a task. You should transpose like this, but not by using the transpose function. Is there another way of transposing a variable to get this result? Yes, there is. You could use the for function. Let me show you. It's very simple. Take this variable. I say for. I use the same index variables here now. Oh, no, sorry, I revert them. I switch them. I equals 2015 to 2020. I think that was it. And I equals 1 to 2, like this. New line. And here simply we pick this one. But here we need the int first, then I. No, sorry. Did I? Oh yeah, sorry. This one should be in like this. Now it's transposed. I pick the second dimension first, and the first I put last. So I switch them. Well, you see, I get the same result. Same transposing result. Sometimes you may wonder, what if we change this one now? If I change this one to 2019, like this, then you see the transpose worked fine, but not the for function. Then I would show you a small tweak you could do here. That's because this I is out of range. I'm trying to go to 2020. Of course, I could use index here and get a question mark. But what I actually want is to make this one follow the other one. And I could have used a global range, but I could also use a function called dim. I want the dimension of that variable. Which dimension? In that case, it is a second dimension. So now I got 2015 to 2019 as my first dimension here, because that's my that's the result of this dimension function. One last thing I would like to show you is the ability to create dynamic ranges. There are many ways or many kinds of dynamic ranges. The most useful one is the one I did show on the Excel webinar, where we created an array based, or created a range, sorry, based on some elements in Excel. But it could be easier than that. If we have now the value 55, and dimension for that one should be my range tests. I put the range test there. If I do so and reset the model, then you see I get 8 55s because my range test goes from 1 to 8, as you see here. I could change this so it goes from 1 to 3, for instance, like that. Back to shared diagrams. Then I have 3 elements. But if making it dynamic, then the user could change this. And that could be very useful. So I go into my global ranges, into range test, and you see here I can check dynamic. Other ways of making it dynamic is, for instance, this database enumeration range or Excel range. Excel range is the one we have showed before. But now I keep numerical. I just make a numerical subrange dynamic. If doing that and going back here, there's actually no difference. It's still free long. I need to do something to change it. To do that, I could use a slider, for instance. In this case, I don't want to put any variable into the slider. I want to select the parameter, double-clicking the frame of the slider into parameters. Here you see I have all the variables, but I don't want any variables now. I don't want to use simulation control. I could set start time, for instance. Very useful that. But I want in here on dynamic ranges, I have this range test because I checked the dynamic checkbox. Then I have the ability to set the first and the last element of this range test. So I double click last and it comes here, click OK, and now you see if increasing here, then it increases the number of elements in this constant because the constant is using the range test. Very useful. Many elements, 20, that's okay. And increase it, decrease it. So it's a very nice way of being able to change number of elements. So there is a production example with Powersim where we're using dynamic ranges from Excel. You could look at that if you want to. Any questions to this? We are a bit over time now, sorry for that. But I hope you have learned something. And we have recorded this webinar, so you are able to receive it by email. We will select this one or the previous one. I think this one is the most smooth webinar, so this one will be available. We will send you an email with links. If you don't get that, you could email us and we will send it to you. We may make a web page where you have links to all the webinars. Okay, thank you for listening. I guess there are no questions. I don't see anything on the chat. So have a nice day and good luck with your modeling.